Hey guys, welcome back to Math with Mr. Fackenthal. Today's lesson is on Chapter 1, Section 3, which is solving equations with variables on both sides. We took a look at this in the activity, but we're going to get further into it now. This is a long one, so take your time, copy everything down, and then we will be moving on. So let's get started. Alright, today's first key idea, solving equations with variables on both sides. To solve equations with variables on both sides, collect the variable terms on one side and the constant terms on the other. So basically we want to end up with our variables on one side of the equal sign and this and everything else on the other. So we want everything else. So our first example today is solving an equation with variables on both sides. This is example 1. They want us to solve 15 minus 2x equals negative 7x, and then check the solution. So, first thing we have to do is always write the equation. 15 minus 2x equals negative 7x. Okay, so remember we said we want to get all the variables on one side of the equal sign and everything else on the other. So the first thing, we want to get rid of this negative 2x. So we add 2x to both sides. These cancel. This leaves us with 15 equals negative 7 plus 2 is negative 5x. And then we have to divide each side by negative 5 to isolate x. Negative 5's cancel, and we're left with x equals 15 divided by negative 5 is negative 3. So x is equal to negative 3. And just like all of our other equations, we can plug it back in and check our answer just like we did over here. So you plug in negative 3 for x, simplify, solve, you get 21 equals 21, so our answer is correct. Example 2, using the distributive property to solve an equation with variables on both sides. So they want us to solve negative 2 times x minus 5 is equal to 6 times x minus 1/2 x. So the first thing, like always, we just write the equation. Negative 2x minus 5 is equal to 6 times 2 minus 1/2x. First thing we have to do is distribute, but we have to distribute on both sides, so we're going to be doing this twice. After we distribute, we're left with negative 2x minus 5 is equal to 6 times 2 is 12, minus 6 times negative 1/2 is negative 3x. Okay, now we want to get all the variables on one side of the equal sign and everything else on the other. So the first thing we're going to do is we're going to add 3x to both sides. It's the inverse of this. This will leave us with negative 2 plus 3 is 1x, or just x, minus 5 is equal to 12. So these cancel. Then we just add 5 to each side, inverse operations, and we are left with x is equal to 17. So x will be equal to 17. That is our final answer. We can plug it back in to check just to make sure. Alright, so our second key idea today, before we discuss this, every equation we've solved so far has had an answer, has had a numerical answer. We got x or y equals a number, and that was our answer. But some equations do not have one solution, like the ones we did. Equations can also have no solutions or infinitely many solutions. This is important. No solutions or infinitely many solutions. When solving an equation that has no solution, you will obtain an equivalent equation that is not true for any of the variables, such as 0 equals 2. So if you solve a whole equation and you come up with an answer such as 0 equals 2 or 3 equals 4, something that's just not true, you know you have an equation that has no solution. So example 3 has us solving an equation with no solution. So they want us to solve 3 minus 4x equals negative 7 minus 4x. So first thing we got to do is just write it down. 3 minus 4x equals negative 7 minus 4x. Okay, so the first thing we have to do to solve this, we want to get all the variables on one side of the equal sign and everything else on the other. So let's add 4x to each side because that's the inverse property. So if we add 4x and add 4x, well, the negative 4x plus 4x is 0, so that leaves us with negative 7 on this side. And then negative 4x plus 4x is 0, so that leaves us with 3. So we have the equation 3 equals negative 7. So we know 3 equals negative 7 is untrue. If you had $3 and your friend owed you $7, you guys don't have the same amount of money. So we would write that this answer is no solution. So this is how you solve an equation with no solution. It's very important to note when solving an equation that has infinitely many solutions, that was our other option from the last key idea, you will obtain an equivalent equation that is true for all values of the variable, such as negative 5 equals negative 5. So if you get an answer where they are equal, any number you plug in would make it true. Whereas on the contrary, what we just did, no solution, there is no number that you can plug in for x that will make this a true expression. So let's try some infinitely many solution problems. Okay, so now we're going to solve, this is example 4, we're going to solve an equation with infinitely many solutions. So the first thing we have to do, write the equation, 6x plus 4 is equal to 3 over 2x plus 1. First thing we have to do here to solve is distribute that 4 throughout. So we rewrite it down here. 6x plus 4 is equal to, well, we know 3 over 2 is the same as 1/2. So we could do 4 times 1/2, x, will give us 6x plus 4 times 1 is 4. So the first thing we have to do, we want to get all of the variables on one side of the equation and everything else on the other. So let's subtract 6x from this side. It's the inverse operation using our inverse properties. So subtract 6x from each side. Well, here 6x minus 6x is going to give us 0. So 4 is equal to 6x minus 6x will give us 0. So we're just left with 4. Well, we have the expression 4 equals 4. So this is going to have infinitely many solutions. This is the symbol for infinity. And what this means is that we could plug any number in for x. We could plug any number in for x and get an equal, and it would work. It would satisfy the solution. So think about it. If we plug 2 in for x here, we'd have 6 times 2 is 12, plus 4 is 16. Over here, we would have 6 times 2 is 12, plus 4 is 16, so 16 would equal 16. We could do 3, 4, 5, any number. There's infinitely many solutions to this problem. Alright, example 5. We are going to write and solve in equations. We should have a lot of practice with this by now because we spent more time after 1.2 working on it, but let's go over it again. So the circles are identical. What is the area of each circle? Well, we know the radius here is x plus 2, and the diameter here is 4x. The circles are identical, so the radius of each is the same. We know radius is half of the diameter, so we can say that the radius of this circle is 2x. So we'll say that the radius right here is 2x. So now we can set up an equation. We know x plus 2 is going to be equal to 2x because these circles are identical. So let's write it out. x plus 2 equals 2x. Now we need to solve for x. We want to get all the variables on one side and everything else on the other. So let's subtract this x, because this is positive x, so the inverse of that will be to subtract x. Whatever we do to one side, you have to do to the other. So the x is canceled. This will be 2 is equal to, and we have 2x minus x is just x. If you have 2, you take away 1, you're left with 1. So we can find out that x is equal to 2. But we're not done yet. They want to know the area. They want to know the area of the circle. So now we have to use the value of 2 in for x and plug it into our formula for the area. Well, first we need to find out what is our radius. Well, let's plug 2 in for x. X plus 2 is our radius. So 2 plus 2 equals 4. So our radius is 4. Our formula for finding the area of a circle is pi r squared is equal to area. So we just plug in 4 for our radius and solve. So we get pi times 4 squared is going to be equal to our area. 4 squared is 16. So our final answer is going to be 16 pi is equal to A. So the area of each of these circles is 16 pi. So our final answer is going to be C, 16 pi. This is tough. This is a tough one, so go back, take a minute, watch this part again until you really understand it. You're going to have a lot of problems like this on the quiz and test coming up. Alright, our sixth and final example is going to be our real-life application. A boat travels X miles per hour upstream. X miles per hour upstream. On the return trip, the boat travels 2 miles per hour faster. How far does the boat travel upstream? Well, the distance upstream is the same as the return distance. So upstream, they're going X miles per hour. So it takes 3 hours times the number of miles per hour is going to be equal to 2.5, which is the number of hours, times the speed, which is x plus 2. So we're just multiplying the time by the speed. So the speed upstream took 3 hours, and then the speed downstream took 2.5 hours. So now we just have to distribute this and solve. So we have 3x is equal to, we have to distribute this 2.5. That's going to give us 2.5x plus 2.5 times 2 is 5. And then now we have variables on both sides, but we want to get all the variables on the other side, on one side, and everything else on the other. So we'll subtract 2.5x from each side. Subtract 2.5x. That's going to be 0.5x is equal to 5. Now we just have to divide each side by 0.5. So that's going to leave us with x is equal to 5 divided by 0.5 is 10. So they want to know how far does the boat travel upstream. Well, we know now upstream it's going 10 miles per hour. Downstream it's going 12 miles per hour. So for upstream, if you travel at 10 miles per hour for 3 hours, so 10 times 3 hours is going to be equal to 30 miles. So the distance How far does the boat travel upstream? It goes 30 miles upstream. Alright, don't forget to like and subscribe and turn on notifications so that way you know every time I post a new video and you can be ahead on all of your notes. Good luck with all this. If you have any questions, go back and look at them and bring your questions to the class. Alright, that's it. Happy solving.